This is a Planar PL1900-BK monitor, PL1900-BK. This monitor is a 19-inch 4:3 aspect ratio monitor, and it requires an external power supply brick. Now, this monitor has a problem. When we connect it to external power, this is what happens. The monitor flashes on momentarily, the power light comes on momentarily, and then it goes out. You see the same behavior here on the power supply brick. The light goes on and then off. The problem is not in the monitor, the problem is in the power supply brick. These power supply bricks for this particular monitor fail with a very, very high frequency, and it is caused by bad electrolytic capacitors. We're going to take this power supply brick apart to find the problem and see if we can fix it. Now, before you begin, I just want you to know this is fairly involved, fairly difficult, and you can actually purchase these for about $12 on eBay. There's a number of sellers, $12 including shipping, so it might be easier just to go buy one of these. But if you're feeling adventuresome, then we'll go ahead and take this apart and fix it ourselves. Now, the problem with this power supply brick is it really wasn't designed to be taken apart or fixed. You can see that it's got a seam running through it all the way around. Basically, these two pieces of plastic are glued together. In order to open this thing, we're going to have to pry it open. It's going to take a hammer and a big screwdriver. I'm going to get the blade of the screwdriver into that seam, and I'm just going to start pounding away. Kind of brutal, but there's no other way to get into this thing. And we'll do the other side. Okay, we've loosened it up. Okay with it, and now if we take a look in here, you can see 3 purple capacitors. That is the problem. That's the part that has failed. And those are what need to be replaced. The power supply is encased in metal. There's a top and a bottom piece. In order to open this up, we're going to have to remove some of that tape. Really, you only need to get this one side off. If we remove this piece of tape, we'll be able to separate one side and expose the electronics. If you happen to have a heat gun, that's always nice. I happen to have one. And if you just heat it up, I find that any sort of adhesive, any sort of tape comes off easier when it's been warmed up. I'd like to keep it intact since we're going to be reusing it. Okay, with that tape partially peeled back and removed, we can now open up that top shell and partially expose the electronics. Get a better look at these 3 bad capacitors. You'll notice that they are partially swollen and some material dripping out of them. In fact, on the lid here, you'll see some staining of the metal caused by spray coming out of those capacitors. We need to expose the circuit board so that we can desolder these capacitors. Unfortunately, it's still held in place by this bottom piece of metal. It's held in several ways. First, there are screws here and here. Okay, there and there. Those 2 screws will have to be removed. Then these 2 clips will have to be removed. These clips basically force these transistors tightly against this metal, acting as a heat sink. And then lastly, we've got these solder bridges here. The circuit board itself is actually soldered to the metal. Here and here. So those 2 points, those solder bridges will have to be broken. Okay, so we're going to start by removing these 2 screws. Okay, go ahead and pull those 2 screws out. Next, I'm going to pop off these 2 clips. Just take our flathead screwdriver and just sort of get on them. They're just sort of held on with pressure. You just got to get under them and just sort of lift them off. We'll be popping them back on later. Okay, there goes the first one. And the second one. Now, the last part's a little trickier. Breaking these solder bridges. They're basically grounding this power supply to this metal can. I will start with the one on this side. Okay, I'm forcing a screwdriver in between the circuit board and the can, and just applying some gentle pressure so that when this solder melts, it will actually come apart here. There we go. Now we get the one on the other side. Screwdriver inserted just for a little gentle pressure while we are heating it up. Okay, it looks like we got the second one. Okay, so now the circuit board is loose and we can just slide it out. Okay, so we will now desolder these 3 capacitors. That's the other side. 1, 2, and 3. Those all have to be removed. The holes for the leads are actually fairly large, so we can probably get away with just putting a big blob of solder on here using our solder sucker. Get a big old blob on there. Let's see if we can't make that capacitor just kind of drop right out on its own. And that's one lead. Let's try the other. Let's see. One lead is loose, the other is hanging on by a thread. There it goes. First one is out. Just a word of caution. The back of these transistors, of course, we have a heat sink compound, and this stuff is really a silicon grease, and if you get it on your clothes, you're never going to get it out, so be careful. Try not to touch that stuff, and certainly don't get it on your clothes. We're going to go ahead and remove those other 2 capacitors. Okay, capacitor number 2. Blob on there. Let's see if we can get it to drop itself out. 2. Okay, actually it just fell out. Good. We'll go ahead and take out number 3. Okay, I just did the same technique. Capacitor number 3 just fell out. Okay, all 3 caps are out. Here's the 3 bad capacitors that we just pulled out. I've seen this particular capacitor before in other devices. Brand name is Hermei, H-E-R-M-E-I, 1000 microfarad 25 volt capacitor. Same darn purple cap. I've seen this in other devices. It's just a terrible capacitor that just seems to always fail. Anyway, we're going to be replacing it with 3 of these much better quality Suncom capacitors. Of course, same size, 1000 microfarad 25 volt. These electrolytic capacitors are polarized. It does make a difference which way you put them in. On the circuit board here, where the capacitors came from, you'll see half of it is white and half of it has no color. The white side is where the negative terminal goes. That's almost always the case. So you take the negative stripe and you line it up with the negative side. Okay, the 3 caps have been put in place. Now we have to solder them down. With the board flipped over, see the leads coming through. I'll bend one of the leads just to kind of hold the capacitor in place upside down while I solder it. Started on this first one here. Now I've got the first lead of each capacitor soldered in place. What I do now is I sort of take my finger and I'll press on it and I'll reflow that solder to get this thing to sit squarely in place so it's not hanging down. There we go. And there we go. Okay, they look good. I'm going to go ahead and straighten out that bent lead. Go ahead and solder those. Okay, all 6 leads are soldered and the capacitors are lined up well. Go ahead and clip those leads off. Just take our diagonal cutters. Okay, all those leads have now been cut off. Capacitors are in place. And we're ready to reassemble. Now we can go ahead and pop the circuit board back into this case. And the next thing, what I'm going to do now is I'm going to put the screws in first. And that way it will sort of line everything up. So when I resolder those joints, everything will be lined up correctly. So screw there and screw there. Okay, I've gone ahead and reinserted those screws. Now the next thing is to resolder these joints. So I'm going to sort of apply some squeezing pressure. So when the solder melts, there it goes. First one. Again, same thing. Squeeze down a bit and go ahead and melt that solder. Perfect. We need to put those clips back on that we took off earlier so that these transistors will be pressing against that heat sink. 1 and 2. Okay, good. It's pretty much reassembled. We can now fold that top back over. And we can reapply this metallized tape. We're going to now put it back in its case. Okay, we will, I guess you would call that the bottom. We'll put this one on first. Tricky part here, getting this cable kind of keyed in there just right. Okay, there we go. Now the other side has a light pipe on it right there, which conducts light from the LED right in there. So the halves are not interchangeable. Okay, finally pop them together. Okay, good. So we are now to a point that we can test this thing. Before I finally seal it up, I'm going to just make sure it's working. Okay, now we're going to go ahead and plug in our power supply and see what happens. Power light come. Aha, look at that. Wonderful. Computer monitor is working. Power light is on consistently. And on the power supply itself, we have a persistent green light. We have fixed the power supply. Again, you can purchase these for, $12 including shipping. But we just fixed ours for about $1 worth of capacitors. Now that we have got this thing working, the last step is to glue these halves back together. And so I'm just going to use a little general purpose glue and apply it lightly around the edges here. Okay, we've applied glue all around those edges there. I'm going to reinsert the electronics. Last thing, I'm going to apply some packing tape just to get it good and tight. I'm going to put in some of this transparent packing tape here. Squeeze those halves together. Just really don't want this thing to pop open on somebody and have them like electrocute themselves or something. So hopefully between the glue and the tape that thing will stay shut. Okay, there it is. Job completed.